And welcome everybody. If you're brand new to this channel, my name is Keith Barker. I'm a double CCNA and sometimes go as the OG of IT. It's great to have you here. I want to share with you a little project that NetworkChuck and I have been working on, and it involved me creating this packet tracer topology and sharing it with him and then having him add some problems to it. So he has done that live stream and he's injected problems and he's given it back to me. And quite frankly, I'm a little nervous. So I have the file. I'm going to download it here in a moment. I also want to share with you where you can download this if you want to go ahead and do some troubleshooting before you watch me attempt to do it right now and have some fun with it. So I wanted to say a huge shout out to NetworkChuck. Thank you for taking a few minutes in your live stream to add this in, the problems that is. And let's go into troubleshooting. So the first thing I'd like to share with you is how do we get this file? And one way of getting it is we could go to Chuck's site, and on his site he has on his YouTube page, he's got this video right here. It's called Help Me Break the Network. And one thing I would encourage you to be aware of, though, that on that channel, on that video, he walks through, and I haven't watched it yet, but he walks through the injection of the problems. So spoiler alert, don't go there and don't watch the whole thing if you want to try troubleshooting it. Another element you can do is you can go to thekeithbarker.com, this page right here. And if you click on downloads, or if you scroll down, you can go ahead and click on this bad boy right here. And let me bring out my pen. So this is the file right here. You can download Cisco PT, NetworkChuck destroyed this network. And that is a zip file that has the PT file and also the instructions of what we're trying to resolve in that file. So Chuck contacted me and said, okay, so how tough do you want this to be? And I said, pretty much anything's fair game. I built this network, so I'm familiar with where things are. Also, I have the subnets. Yep. I have these subnets written down, and these like for VLAN 10 and VLAN 20, so I recall what the ranges are and the IP addresses. I also have the topology written down with the actual interfaces so that I can make sure when we're troubleshooting I'm working on the right interface and going through that right process. And you can do the same exact thing by downloading this file if you want to and practicing it and troubleshooting it before you watch this walkthrough. All right, so with that spoiler alert out of the way, let's go ahead and click on that link. And it says what I want to do with this file. I'm going to go ahead and save it. And then I'll take a look in the folder, which is my downloads folder. And there it is. So there's my downloads folder. There's the PT Lab, Troubleshooting with NetworkChuck. Right click, extract, and extract. And there are the two files. Now, this is using Cisco's Packet Tracer. If you're not yet using Packet Tracer, it's a great simulator for network configuration and practice at the CCNA level. It's fantastic. You can get a free copy by going to netacad.com, signing up for a free account, downloading Packet Tracer, and I'm using 7.3 and change, that version, the current version as of this recording for the Packet Tracer. So this PDF file, I put that there, and the PDF file simply explains what this is all about. And it's NetworkChuck and I with a collaborative project. And again, I thank NetworkChuck for taking time to inject hopefully some really challenging problems. And this is where we downloaded the file just now. And the objectives, I asked Chuck, okay, so what is the objective? What do we need to accomplish in this lab? And he said, you need to establish full connectivity between all the client PCs. And I just copied and pasted that from our chat. And then also here in this PDF document, I've got the spoiler alert links. This is a link to NetworkChuck's his video where he injected the problems. So again, you can watch that after you try it on your own if you want to. And right here is the link for this video. So I'm recording this video. The camera's rolling. I'm not going to cut. I'm not going to edit. I'm just going to let whatever happens and do the best I can in troubleshooting the problem. And it'll be available at this link here so that you can watch the me do the walkthrough. So watch Chuck break it here. Watch Keith try to fix it here. And this is also a link for the CCNA playlist on YouTube. I also included links for Chuck's NetworkChuck's Discord server. If you want to join that community, I think they have like 11 billion users. It's great. And I've got we've got a fairly smaller community on my Discord server. Feel free to join both if you want to continue the discussion and have chats about things regarding in our channel in the Discord server about CCNA related topics. All right. So having said that, let's go to my downloads folder. And let's go ahead and open up itsbroken.pkt. That's the file that he gave me. I downloaded it. I went to that page. He had it tagged as a comment, a pinned comment, And I just I'm not looking at the comments because I don't know what people may be saying. So I just downloaded it and that was it. So here it is. Let me size it up. I also had previously logged in on this computer to Packet Tracer. So when you launch Packet Tracer, Cisco wants you to log in with your Neticat account, which I already did. So let me size this up a little bit and make sure that we can all see it appropriately. And that's going to take a little bit of navigation with the little net crane on my part as I look at the second monitor here. All right, so it looks like that part's lined up. That's great. And so is that. And then we'll stretch the right-hand side over a little bit. All right. Well, okay. Let me turn my camera back on there. Okay, so again, thanks to NetworkChuck for putting this together for me. I like the background here. Now, for me, when working with this network, it's not going to be as easy to see port labels and other indicators if I have this bitmap in the background. So the first thing I'm going to do is, let me see if I can hover here. Oh, my face is in the way. I get rid of my face. I believe here we can click on, there we go. This little mountain with the little sun over it is set the background image. And I'm just going to go ahead and click on reset here. And that, just so I can see better the topology and the interfaces and have a little less distraction. All right, so I'm going to click on apply. Click on close that. Fantastic. And let me bring this up. And I'll make it a little bit smaller. And if you want to download the Packet Tracer file and just to have it open so you can see all the interfaces involved on your own computer while we'll go through this together, that's great too. I just want to be able to make sure we see everything. Okay, now one of the challenges that I mean, for me to have a fair shot at solving this, see how these interfaces are like lopped on top of each other. I've already taken the time on my topology diagram to, on paper, write out all those ports and where they connect. So I'm going to, for the sake of this lab and just doing it right now, I'm going to go up to options. And then from the options menu, I'm going to select preferences. And then from preferences, I'm going to go ahead and I'm going to say, don't always show port labels in logical workspace, just so I can kind of have a little clarity. And then I also want to, this option right here, show port labels when mousing over. I want that. So I'm going to go ahead and leave them like that. And then I can hover over these and it should show me the, oh crap, hold on a second. It should show me the ports involved. Why did it do that? All right. All right, so I need to, if I want to look at those ports, specifically the port numbers of where they're connected, I have it on my separate piece of paper. If I need to view them, I guess I can go to view our options. Oh, this is where I wish I'd practiced more. On Packet Tracer, options and preferences. Let me just take a look at that one more time. Place down, show model labels, always show, disable auto cable, align. Oh, look at that. I thought that was on. The show port labels when mouse over in logical workspace. I thought that was on. All right, I guess I misread that. All right, so now if I hover over one of these, there you go. Now it shows me the port. That's what I need. I want to make sure that if I'm configuring the port or an interface, that I want to make sure I'm working on the right interface. So now I can hover over those and get that information. Okay, great. Now we are ready. So thanks for giving me a moment to set up. Okay, so the objectives are, let me get my pen out here. The objectives are to go ahead and make sure we have full connectivity between all the clients. And so the clients are here, 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 and here. And this network up here, this client is in VLAN 10, based on how I built the network. And this internal server, which is acting as a DHCP server, is at 10.67.83.3. That's also in VLAN 10. And then I use a different color over here. This is VLAN 20. And this client should be getting an IP address from this DHCP server, which implies we have DHCP helper involved. As I'm looking at this topology, we shouldn't have a whole bunch of traffic happening, maybe some BPDUs and such, but check these LEDs out. They're just on fire. just on fire. And somebody once asked me, "Hey Keith, how do you know if you have a broadcast storm in your network?" I say your wiring closet and the switch ports are going to look like it's Christmas. And that's what this looks like to me as well. So just for grins, let me click on the physical view, and I'm going to click on the little compass here and click on rack, and then click on jump to selected location, just so I can see the LEDs here. And yeah, they're just on fire. So when you have a whole bunch of switch ports that are acting just like lighting up all the time like these guys are, that's it's very likely a layer 2 loop. So there's something going on, or maybe not going on with spanning tree. So we'll have to resolve that as well. In fact, as we take a look at resolving these issues, let me click back on the logical view. As far as strategy goes, I would say from a strategic perspective, let's start small and grow out. So I would say let's first go to this PC and see whether or not it can get an IP address via DHCP. So that 169 right there for the IP address means that DHCP went south. So it did a discover, and the ORA process, the offer request acknowledgement process, didn't finish. So this implies that DHCP isn't working. The DHCP server is this guy right here, the internal server. Let's just go verify he's running DHCP. So we'll go to the server, go to services, and let's work on that first. The client in VLAN 10, PC1, getting an IP address from the DHCP server, also in VLAN 10. So if this is the services tab, here's DHCP. It is on. It is handing out the IP address starting in 5 for this pool, which looks good. The mask is good. And the default gateway is going to be .4, which is my HSRP address. That's good. That looks good. All right, so that part looks good. You know, as much as I want to, we got to do this. Instead of, before, if we were talking about layer 2 connectivity between the PC and the DHCP server and just getting an IP address handed out, if we have a broadcast storm, which appears to me to be happening here, it's going to be intermittent and maybe won't work just because of the broadcast storm. So let's clear up our layer 2 issues with loops, because that's what it looks like here from the LEDs going. And then once we have that solved, then we'll go into the client and see if we can get an IP address via DHCP and pursue that further. I think that'd be a logical, correct way to go ahead and take care of the biggest problems first. All right, so I'm going to get out one of my secret tools here, and that secret tool is called Notepad. All right, so there's Notepad. If I need to make notes, not bad for Notepad. Also, if I need to make changes on multiple devices or keep track, I can do it here as well. So we should have in this environment VLAN. I'm not using VLAN 1, but I'm using VLAN 7 as a management VLAN, VLAN 10 as a user VLAN, VLAN 20 as another user VLAN, and then VLAN 30. So 7, 10, and 30 are my 3 primary VLANs that I'm using. So let's fix this nasty business with spanning tree or whatever's happening here. So let's start at the core. I'll start at MLS1, the multi-layer switch, bottom left, and let's go to the CLI. So it's powered on. That's always a good thing. If we went to the CLI tab and it wasn't powered on, it wouldn't give us the CLI. So we'll go into privilege mode, and let's do a show VLAN brief. Start there. Okay, I'm looking real hard. We have the LEDs still flashing like a madman, but I don't see VLANs 10, and I don't see VLAN 20. So as a result, if you want the core network, the multi-layer switches to route with switched virtual interfaces for those VLANs have to exist. So let's go ahead and let's see where they exist. Let's do this command on all 4 switches. So access layer switch. This will also queue up our windows so we can just click and go in the future. Show, this is access 1, show VLAN brief. Okay, so it's missing VLANs 10 and 20. And let's go to access list, or access switch 2. Which that little LED indicator there doesn't look good going out to the client PC2. Anyway, we'll take a look at that in a moment. And we'll do a show VLAN brief. Oh, good. At least they're all consistent. They're all missing they're all missing VLAN 10 and 20, and we'll verify that on MLS2 as well. Show VLAN brief. Okay. Yeah, consistent across the board. We're all missing VLANs 10 and 20. So we need those VLANs. Let me bring this over so it doesn't wrap quite as much. There we go. So we need those VLANs. We certainly need VLAN 10 and 20 for the clients involved. So let's go ahead and let's create them. And then we'll solve the spanning tree problem. So config T, VLAN 10. Okay, and VLAN 20. So because we had the VLANs didn't exist, the interface VLANs for VLAN 10 and VLAN 20 were down. And now that those interfaces, those VLANs exist, and there's trunk ports associated with them, now they're coming up. So let's do a show VLAN brief. Okay, so now we have those two VLANs, and let's do a show interface trunk. We could make this really simple maybe. Show interface trunk, and I'm just going to go scroll to the top here. Oh, we have 802.1q trunks everywhere. That's the HTSRP message popped up down there. So we have trunks from MLS2. We have 1, 2, 3, 4, 5. 1, 2, 3, 4. This is showing we have 5 trunks on this switch, which means our trunking is working. Let's take a look at VTP, because I configured VTP also, I believe, in my lab to show VTP status. So he's a server. Well, if he's already a server, maybe it's already created. So if we do a show VLAN brief, those VLANs 20 and 30, I'm sorry, 10 and 20 may have already been propagated to the other switches. Let's go to MLS1, show VLAN brief. Yep, it knows about them now. VLAN 10, 20, access 1, show VLAN brief, 10 and 20. Oh, no 20. Why is that? Now, I don't actually need VLAN 20 on access switch 1. And so I'm not going to pursue troubleshooting why it's not there, because I have no clients in VLAN 20 hanging off of access switch 1. But let's go to access switch 2 and do a show VLAN brief. And it's got a VLAN 20, which is great. All right, so we have all the VLANs that I think we need in our headquarters site. That's great, but we still have these blinking lights. They're going crazy. Here's the physical view, little LEDs. Brrr. So let's fix what's causing that. So if we go back to the logical view here, and I'm going to start on the core MLS1, and we have these VLANs 1, 7, 10, 20, and 30. And if we do let's do a show spanning tree for all of them. So just show spanning tree, and press enter. Oh, that's great. Oh wait, classic, good stuff. So if spanning tree is disabled for all of our VLANs, that would definitely explain why we have a loop happening. So I think if we go to access switch 1, show spanning tree, and we can also show spanning tree for a specific VLAN, but yeah, it's not there at all. MLS2, show spanning tree. All right, so spanning, and I'm just going to guess on access switch 2, it's probably the same thing. So if we just show, let's see here, what interface is this guy right here? That's gig 1022. Let's do this. Let's do a show interface gig 1/0/22/22. There we go. Yeah, 1,000 broadcasts. Now in a production network, it would probably be way higher than that if we have a broadcast storm that's just looping, 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 looping. So it's 956. If we do it again, oh, received. All right. So in a input back. So in a production network, if we had a broadcast storm happening, we would actually see just that broadcast number getting higher and higher and higher and higher and higher. That's all right. So loops at layer 2 are no good, and spanning tree, because it's disabled, is what's causing that. So let's enable spanning tree. So spanning tree, it's not running anywhere. So let's do mode rapid. And let's also do spanning tree for VLAN 1. Oh, you're going to make me do them manually? Dash 1,000? Okay, good, good, good. So context sensitive help wasn't sending that to me, but if you do now show spanning tree, there we go. So if we scroll up a little bit, there's spanning tree for VLAN 1, VLAN 7, VLAN 20, and VLAN 10. Did I miss that one? Yep, there it is. That's all there. So I'm going to go ahead and do that same command. So in configuration mode, there's two history buffers, one for privilege mode, one for configuration mode. So if we do a do show history here, it'll show us our commands that we've done in configuration mode. I'm just going to take these two and right click and copy, get out notepad, config T, and I'm just going to paste that in and save it as we go. All right, copy that, access switch 1, paste. Oh, look at this. Spanning tree block BPDU guard. BPDU guard? What the? That's not nice. That's fantastic, though. I love it. I don't know if I would be looking for that had I not seen that. But also, this just raised the game to a whole nother level because I wasn't considering that you'd be using security measures inside of the lab topology, including things like BPDU guard. That's literally what's going on here based on that message. And it put the port into an error disabled state. All right, let me finish my configs, and then we'll come back to access switch 1, and we'll solve that. So I'll paste that, and we'll go to access switch 2, paste that, and we'll go to MLS 2, paste that. All right. You see how all the interfaces have stopped? And that's because spanning tree has now identified root bridges and root ports and designated ports and all that content we've talked about in a few videos in the master playlist here on YouTube. So if you need to catch up on spanning tree and how it operates, that would be a great place to do it. Okay, so now let's go up to this access layer switch. And this says that receive BPD on gig 0/2. Let me make sure. Is that this port? Yep, 0/2. So it received a BPD on this port and it shut it down. So BPDU guard is a great thing. If you have access ports that should never be receiving BPDUs, and a hacker like with Kali Linux or something starts to send BPDUs in, if you have BPDU guard, it's going to go ahead and just say, nope, I'm going to go ahead and bring this port down. That's mean. I mean, that's great. It's great for the lab. So let me let's take a look. Let me see if I can grab the edge of this. I can't grab the edge of that. Hold on a second. Oh, there we go. Okay, thank you. So gig 0/2 is down, and if we do a show interface status, so that'll and we have our gig. Here we go. Yeah, right there. So we can also do like a show interface status error disabled. I don't know if Packet Tracer supports that command or not to see just the interface in that state. I think there's also a command like show interface, show status. Sorry, interface status. Oh yeah, it's not giving me nothing. All right, so to refine that further, I already know what happened because I saw the console message. So let's go ahead and do a show run begin BPDU. Oh, I love this. Oh, I love this. This is fantastic. You know, if you want to in an attack, if you send in like thousands and thousands of non-malicious traffic that might look like they're malicious but they're not, it makes it more difficult to identify where the problem is. This is great. This is great. So it looks like all those lines have the word Keith in it. Let's do this. Let's do begin. How about a show run, and we'll do exclude any lines that have the word Keith in it. And what that will do, there's our spanning tree port fast BPU guard default. Nice. Anyway, as we go through this, it will just remove any lines that have the word Keith in it, so I don't have to sort through them. Oh, and DHCP snooping is on here. Oh, well, that's great. Okay, I'm so happy to see this. I probably wouldn't have looked at the running config on this if I wasn't trying to track down the BPDU guard, but check this out. With DHCP snooping, which is a fantastic security measure, it's enabling it for VLANs 10, 20, and 30, and that basically means that any DHCP server messages are going to be dropped as they try to come into the switch on those VLANs if those ports are not trusted ports. So I'm going to put that in my memory bank as a reason that we might not have successful DHCP services here coming up if it's not configured correctly. We'll see. Maybe it is. I don't remember putting that into my initial lab, though, so because it's here now, it makes me suspicious. All right, so let's do this. I'm going to hit Q for quit and config T, and we'll say no, and we'll say spanning tree port fast BPDU guard default, copy, paste with a no in front of that, and then we'll do the show command again. So show run, I'll do a do in front, do show run, exclude Keith. All right, now I'm just gonna look for everything. DHCP snooping is still on, that's gonna be fine. I need to make sure that we're allowing the server to respond. Oh yeah, here we go, IP DHCP snooping trust. So we've got a trusted port. Yep, let me check the ports here. Oh, okay. So FA0/1 is the client, which is the trusted port, and FA0/2, which is going to the internal server, we shall see. Oh, it's not trusted. Oh, and they also have duplex half. All right. Well, I'm going to tell you what. Instead of making FA0/2 a trusted port for DHCP snooping, I'm going to go ahead and just turn off the security feature because, oh wait, it's the only DHCP server that we have. I guess I could just make it a trusted port. So interface FA0/2, IP DHCP snooping trust. All right, so now that port's a trusted port. And the duplex halves, why are those? Oh, look at this too. So FA0/1 is in VLAN 10. This is the interface that goes off to the client. And interface 0/2, which goes off to the server, is in in VLAN 7. And so we can verify that with the do show VLAN brief. Yeah, look at that. These two ports, FA0/1 and 2, they should both be in VLAN 10. And the FA02, which goes to the server, is in the wrong VLAN. So let's do this. Interface range. Yeah, let's do interface range. FA0/1 through 2. Switch port mode access, even if it's already on, it's going to do it out of good habit. Switch port access. VLAN 10. Do show VLAN brief. All right. I'm loving it. Okay, so now we have these two ports, FA0/1 and FA0/2. These two guys appear that are both in the right VLAN. Spanning tree no longer looks like Christmas time with all the lights. And let's see here. Let's go take a look. So if we hover over this client, oh, it got an IP address already. 10.67.83.5. I'll keep hovering over it. And we can also look at the command line of that PC. And go to the desktop, go to command prompt, and do ipconfig. ipconfig/all. And the DHCP server is 10.67.83.3. Got the right IP address, or got an IP address. And let's see if it can ping its default gateway, which is .4, which is an HSRP address. So we'll do a ping 10.67.83.4. All right, the struggle is real. Okay, so let's talk about what we've done so far. We have identified that these ports were not both, and I'll arrow this, I'll put a pen on this. These two ports were not in the same VLAN. In VLAN 10, we fixed that. We turned on spanning tree. We disabled BPDU guard on, I think it was this interface right here, which was causing it to go into error disabled state. And we now have an IP address that this PC got from this server, along with the default gateway of .4 of 10.67.83.4, which I believe that's the DHCP, the HSRP address. So let's do a couple tests real quick. This IP address this multi-layer switch on VLAN 10, its interface VLAN 10 is .1, and this multi-layer switch on VLAN 10 is 1067.83.2. I'm just going to verify I can ping both those IP addresses, and if I can, and I can't ping the .4, then I'm going to go tackle the situation about why HSRP isn't working. All right, I am in. This is great. This is fantastic. NetworkChuck, thank you for putting this together. I am literally having a great time because, I mean, that BPDU guard, I was not expecting anything like that in this lab. All right, so going back to the PC, we already pinged the server, I think. 83.3 is the server. Okay, and I want to see if I can ping 83.1, which is the multi-layer switch 1. That's curious to me. All right, this let's see if the server can ping the default gateway, that IP address. So on the server, going to go to the command prompt and do a ping to 10.67. I need to make sure my typing is correct. 10.67.83.1. And it can't either. Oh, that's the wrong address. Oh my gosh, that's the wrong address. 10.67.83.1 I think is the... Let's take a look. Let's go take a look. So MLS1, let's take a look at it. And we'll do a show IP interface brief. And its VLAN 10 interface is 10.67.83.1. 10.67.83.1. This PC is in VLAN 10. I'll verify that on the switch port. FA0/1, VLAN 10. The PC, 10.67.83.1. Huh. I mean, we're on the same network. Let me see if I can ping .2, which is MLS2. Let me verify its address. So yeah, 10.67.83.2 is its address. And we're not talking about routing yet because this is just the same local VLAN. So let's do a show IP interface brief. And VLAN 10 is 10.67.83.2 from the PC. Ping 10.67.83.2. All right. What the heck is going on here? Well, let's take a look and see if there's... Let me do a quick check. I honestly don't know why that's working or why that's not working. Let's just do a quick check of all the pieces here. So this, if I hover over access switch 1, FA01, which goes to the left, is in VLAN 10. It's up. Interface FA0/2, which goes to the right to the DHCP servers in VLAN 10, it's up. If we ping from this guy to the server and then go to the MAC address table, that's packet trace. Normally those MAC addresses will be there for a little bit longer. I'm going to go ping again and then go back to the access layer switch and do an up arrow key. There we go. So all right, so it's dynamically learning those addresses. Huh. Why can't I ping the default gateway at MLS1 or MLS2? I do not know. Let's find out. Let's do a ping again to .1. And that's failing. Let's take a look at the ARP cache. And it didn't even learn it. So the ARP didn't resolve. The ARP did not resolve the layer 2 address of MLS1 at .1. All right, so we have, let's check our trunks. Let's go back to the access layer switch, do a show interface trunk. So gig 0/1, which is, oh, hold on. don't delete that. This interface right here, which is gig 0/1, is on. Oh, I don't see the trunk going down the other one. That's okay. So, and it's carrying VLAN 10 traffic. So that should be working. If we do a show interface status. Okay, gig 0/2, which goes down to core 2, is disabled with the error disable. Why is that? Let's check it out real quick. Show run pipe exclude Keith. And let's take a look at gig 0/2 and see if there's anything funky going on there. Switch port mode trunk. Oh, and port fast is on gig 0/1. That shouldn't be devastating. Because port fast just goes to a forwarding state a little bit faster, but it's not, shouldn't break it. I'm going to turn that off though, because I am not having traffic flow down. And that is gig. Let's just do this. This is this. I'm going to copy that. Press enter. Paste it in, and then do a Control A. And do a no. And then I'm going to do a shut on that port and a no shut. VLAN 7. Oh, which port am I dealing with here? Gig 0/1. All right, that's okay. Show interface trunk. Gig 0/1 says it's trunking. Gig 0/2 is error disabled. I want to fix that right now if I can. I'll do a shut on gig 0/2 and a no shut. Give it a second. All right. Huh. Okay, so I'm going to go back to the PC1 and I want to see if I can ping my the IP address of .1. Which is the IP address of the multi-layer switch SVI for interface VLAN 10. It is not getting there. All right, let me take a look at the trunking again. Make sure we have trunking that's working. Show interface trunk on MLS. You know what I'm going to do? I'm going to make MLS1 just to make sure our spanning tree is all copacetic. I'm going to go ahead and make it the root for everything. Oh, and I've got to do it per VLAN. Maybe I don't want to do it for everything. Oh, I can do a range. Here we go, yeah. 1 through 100. Root, primary. I just want to force all the traffic down through MLS1 to reduce my troubleshooting real quick. All right, so I see some LEDs down here that don't look too healthy either. Okay, so, all right. So far we've covered, this is giving me a chance just to think. We have PC1 and the DHCP server that are now communicating with each other. We are now having a problem communicating to the MLS interface. Let's just show IP interface status. Show interface status. Make sure all of our ports here are good to go. I have nothing in error disable state. Show interface trunk. So it's 101 that's going up to the access layer switch. Oh no, it's 1021 that goes up to the access layer switch. This guy. And he's carrying all the VLAN traffic. And show IP interface brief. And his IP address for VLAN 10 is 1067.83.1. And if we do a ping to 10.67.83.3, that's the server, we're on the local network. We're not even to routing yet. This is the multi-layer switch on the local network, on the local VLAN 10, trying to ping another device. Wow. All right. Let's, and he can't ping A3.2. Oh, he can. So this is MLS1 pinging MLS2 at 10.67.83.2. All right, I'm going to take a look. See, so trunks look good. Show interface trunk. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 interfaces that are trunking. That looks good. And I'm allowing all the VLANs, spanning trees, limiting off 20 there off of 0/23, which is fine. And all I'm trying to do is ping from the PC to the multi-layer switch interface on the same VLAN. Wow, I don't know what this is. Let me just yeah, I don't know what it is. I don't know what it is. All right, Chuck, you may have got me. I'm not done yet. I'm going to leave the tape rolling here as we try to resolve this. Let me check the interfaces. Let's do a show run. Oh, great. Let's do a show run section interface. And maybe another pipe exclude. Let's do exclude. All right. Oh, and he's running a DHCP server. So MLS1 is running a DHCP server for the same network, but the wrong default gateway. The reason that won't matter too much, though, is because if we had a client up here, because DHCP snooping is on, oh, and this is a trusted port. Oh, my gosh. Let's check that out real quick. Gig 01. Let's see if Gig 01 is a trusted port. Oh, it is a trusted. Oh, wait a sec. Gig 01. Sorry, got excited. All right, Gig 01. Switch port mode. Okay. Okay, so why can I not ping down there? Why can I not ping to that device? Show spanning tree for VLAN 10. Why am I the root? Oh, this isn't good. Yeah, this is not good. So this is our access layer switch saying it's the root for VLAN 10, even though I told MLS this switch. First, let me kill that DHCP pool. Okay, it wants the word VLAN. All right. Yeah. So access 1 believes it's the root for VLAN 10, and MLS 1 believes it's the root for VLAN 10. And can they see each other? Hold on a second. Show CDP neighbor. Oh, I can't even see him. All right, I've got a port blocked or something. So off MLS 1, it doesn't see access 1. So let me check these ports real quick. What port is that? That is gig 1021 and gig 01. I'm going to mark those so I don't forget what they are. So 1/0/21, and I'm gonna and 0/1, and I'll verify those right now. Let me leave those up. One 0/21 and 0/1. Okay. Just for my own sanity, I want to make sure that those two ports are working, because CDP, unless it's been disabled, I don't think it has, but it could be. So let's do a show CDP. Show CDP interface. So is CDP running on gig 1021? And it is. And let's also make sure on the access layer switch it's running. And gig 0/1 will be at the bottom here. Yeah, so CDP is running, but we are not seeing our neighbors there. Wow, this is fantastic. I don't know what this is. I don't know why it's happening. So let's do a show CDP neighbors. And access 1 does not show up off the local 1021. Let's take a look at the interface. Show interface status. 1021 is right there. It says connected. Let's go to the access layer switch. Show interface status. And that is 0/1, which is right here. Huh. So let's do a show interface trunk. I don't know what's going on. I love it. I love it. Chuck, NetworkChuck, great job. So 0/1, it says it's a trunk. It says it's trunking. It's allowing. We don't need VLAN 20. That's okay up on access switch 1. Why am I not able to see a CDP message from that? DHCP snooping shouldn't be hurting that. Rapid spanning tree is fine. Port fast default, that's fine. The duplex on all those other ports doesn't matter. Trunks on gig 01 and 02. Yeah. Somebody tell me why we don't see CDP messages between access switch 1 and MLS. So show CDP neighbors. It sees nothing. All right, I'm rebooting the switch. And I'm going to also reboot MLS1. So I'm going to go to physical, and I'm just going to yank out the power supply and go to access 1, physical. Oh, it's got a built-in power supply. All right, I guess I'm just going to bring up MLS1 again. And I'll drop in a power supply and let that come up, and it's on its way. Yes, it's weird. I didn't, we don't see CDP messages between those two. So we have HSRP enabled. That's fine. Access 2. Access 1 doesn't show up. All right, just to confirm here. Show CDP interface. And gig 0/1, which is right here, it's enabled on this interface. And if we go down to MLS and this switch, and we do a show CDP neighbor, or show CDP interface rather, here on its gig 1021, CDP is enabled. So why are we not seeing CDP messages there? Oh, look at this. I've got a broadcast. I've got another storm on going on. Look at those lights. All right, let me just show CDP neighbor. Oh my gosh, this is so great. Okay, so I've got an underlying problem here with layer 2 loops, which has not been solved because it is going wackadoodle right here. These lights are just going crazy. If you go to the physical view, which is always fun to do, these lights are just blinking like crazy. And that's not just BPDUs going back and forth. That is very likely a loop. So let me take a look and see what's wrong, and we'll correct it. And maybe that's why the CDP piece isn't working as well. I'm not quite sure. Let's go to all the switches and do a show VLAN brief 1.7.10.2030 and show spanning tree. Oh, summary. There we go. So show spanning tree summary there. show spanning tree summary. Okay. It means spanning tree is running for all those VLANs, which is great. Oh, where's VLAN 20 here? Oh, we already knew that didn't exist. I'm going to create VLAN 20 here. Oh, it's in client mode. Okay, I can fix that. VTP mode server and VLAN 20. And let's do a show VLAN brief. And we'll also do a show spanning tree summary. Okay, 1, 7, 10, 20, 30. Spanning tree is running there. And on switch 2, show spanning tree summary. Oh my gosh, so good. 1, 7, 10, 20, 30. So spanning tree is running there as well. Why do we have these loops? Because that's what it looks like. It looks like we have... Now, in spanning tree, what happens also is that if you have like 1, 2, 3, 5 spanning trees, which we do in rapid spanning tree, it's going to have 5 sets of BPDUs, but that wouldn't cause all these LEDs everywhere just to go crazy like they are. All right, so I'm going to do this. I'm going to do a file. I'm going to save as, and let me say this, it's broken, and I'll call this Keith. And let me save all my configs too. Spanning tree 1 through 1000, we have it enabled everywhere. So I'm just going to do a quick write on all these devices. I guess I could just type in WR. Oh! Spanning tree is also playing a role on the switch port on the router. Oh, freak. Okay. That could be the that could be the problem. That could be our loop. If it's generating broadcasts and it's gonna forward those, that could be the problem. All right, I hadn't thought of that. Let's do a show spanning tree summary. Yeah, it doesn't have spanning tree running for. It's not supporting VLANs 10 or 20. Oh, and it doesn't have VLANs 10 or 20. All right, show VTP status. Oh my gosh. Now I'm rattled. All right, show VTP status. I'm in transparent mode. Let me go ahead and join the group. VTP status, or VTP mode client, because I don't want to. Oh, maybe I have to do that in VLAN database mode. See here, VLAN database, VTP mode. Oh, VTP client. Exit. All right. Okay, so I got the VLANs. Now we have the VLANs, and I bet you spanning tree is not running on all these. I was just going to enable it. Spanning tree mode rapid, and spanning tree VLAN 1 through 1000, just to enable it on any existing VLANs. And I still see loops happening. I mean, it looks like loops are happening. Wow. Okay. I'm going to do this. I'm going to, I've done a WR on all these devices. Yeah. I'm going to turn it off and turn it back on. And see if it behaves a little better. And then we'll continue troubleshooting. This is fantastic. Oh my gosh. I did not expect it to be this tough. All right. So we'll click on save. And then I'm going to go ahead and save file and exit. And I want to save changes. This is called Keith. And then we'll go ahead and we'll open it up. It's right here. That's the one I just saved a moment ago. And I'll line it up. Give me a moment here. I'll get it sized up so it's nice and appropriate for this screen. And almost there. Okay, all right. So let me make this a bit smaller. And look at this. I don't see all the crazy, wacky loop behavior that I did a moment ago. So we started off because we couldn't see CDP between access 1 and multi-layer switch. And so we I checked, I think, everything. And so rebooting the topology looks like it might have cleared it up. And that is not an ideal scenario. Usually we like to make changes, see those changes happen, but all I just did was save it, rebooted, and let's go back to the multi-layer switch and let's do a show CDP neighbor and see if we can see access 1, see if we have some normality built back in. Show CDP neighbor. And there it is. So I'm not sure what was going on with that loop because we had spanning tree. We did add spanning tree on R1. We added VLAN 20 to it, although I don't know that it needed it. And the loops are no longer there. All right. So that was fun. And let's continue troubleshooting. Our goal is to get full connectivity between all the clients. Let's go to this PC. And, well, you know what? We know this PC already worked. It's got an IP address. If we hover over it, it is .5. And if we go to this PC in VLAN 20, it has an IP address of .21. Let me just check my subnets. So VLAN 20 is the 10.67.83.16 subnet. So that is an IP address in that range, which is great. Let's see if they can ping each other. So this guy is at .5. So let's go to this PC2, and we'll go to the desktop, go to command prompt, and ping 10.67.83.5. Oh, please. All right, so these PCs are oh, there we go. Okay, so perhaps we had 2 routers in the path. Well, I only think we're only 1 hop away, but it could be that it ARPed, the ARP cache gets consumed, that first ping. So let's do another ping. Oh, there we go. And we can also verify the path with a trace. So we'll do a trace RT from a Windows perspective, and we'll put in that IP address of 10.67.83.5. Yeah, okay. So the first hop was .18, which is one of our HSRP, our multi-layer switch routers. And that looks good. Okay. Oh, whew, that was weird. So from PC1 to PC2, we've got our connectivity. Now, let's go ahead and take it to the next step, and that is PC1, maybe, or from this site APC to the headquarters PC. So let's hover over PCA. And it's got the IP address of 10.67.83.71 with a 27-bit mask. And its default gateway is .66. Let's see if we can ping our default gateway. I mean, I'd try the whole thing, but I know there's something else in here probably. So we'll go to desktop and do a ping to 67.83. The period's important. So is the 10. 10.67.83. And then let's, with our default gateway again, it's was it 65? It says 66. This client thinks this default gateway is 66. Which this router doesn't own that IP address. Okay, so let's sort that out real quick. Because if it tries to ping the wrong IP address, it's not going to be great. So 65. Okay, that's router 2's interface here facing the that site. And this guy's got the wrong default gateway, IP config. And let me bring it a little bit bigger. All right, let me check my feedback monitor. Okay, great. So it's got a default gateway of 66. How did it get its IP address? ipconfig/all. And it is a DHCP client coming from the DHCP server 1067.85.65. That means that the DHCP service that's running on R2, because that's its IP address we just looked at, it's handing out the wrong information. So let's go to R2 and fix that. Oh, and because this isn't a server, we get to do it at the command line. There's not a button for DHCP. So we'll go to the command line of R2, and we'll do a show IP interface brief just to verify. So that is the IP address right there that we want to hand out as a default gateway for that local segment. And let's do a show run begin DHCP. All right, so there's our pool. I'm going to hit Q to stop the scrolling. IP DHCP pool, our pool, network 1067.83.64. And make sure that's the right subnet. That is the right subnet. Woohoo! All right, that's good. And the default router is wrong. All right, so what we're going to do is I'm going to copy all of that and go to configuration mode and paste it in. And then I'm going to simply say no for 66 there. Oh, come on. Come on, baby. You can do it. 66. And then we'll hit the up arrow key and take off the no. And we'll also put on a 65, which is the correct default gateway. We'll save that config. We'll go back to the PC. We'll do an IP config /renew. Should renew the lease. That looks better. There's our default gateway. Let's try pinging this PC up here at 1067.83.5 is what it is. 10. So we'll do a ping to 10.67.83.5. Okay. Well, all right. The journey continues. So what this is saying is that this device with this IP address of .65, which we just identified as router 2, it's saying, I don't know how to get there. I would love to take your packet and route it. I know I'm a router. That's what I do for a living, but I can't get there. And that's what literally R2 is saying to us. So now we have a routing issue. Let's solve that first. Let's go to R2. And on R2, we'll do a show IP route. Either he's not running a dynamic routing protocol or something is terribly, horribly wrong. So let's first of all do a show IP protocols and see if he's running. Oh, look at that. So OSPF, process ID 1 is running. Its router ID is 2222. That's great. It could be hard-coded or it could be the highest address on a loopback. Either way is great. And then the network statement says every interface I have that's IPv4 enabled and up, it's going to be in area 0. That's great. And we don't have any neighbors. It's routing information sources 2222. That's like us saying, yeah, I learned it from myself. That's all I know. Show IP OSPF interface. So loopback 0 is included, gig 00 is included, gig 01 is included. That looks good. So why don't you have any neighbors? Show IP OSPF neighbor. Oh. Wait a sec. So here's what's curious to me. As far as OSPF neighbor states go, I had a video that we did together. It was a lot of fun. And one way that we helped remember the neighbor adjacencies with OSPF was the IT elf. Like, you know, the happy guy around the holidays, the IT guy, the elf that hands out gifts and so forth. IT elf is an acronym or a mnemonic for init, 2A, xstart, and exchange, and then loading, L, and then full adjacency. So check out that video on the IT elf if you want to remember those states. But what this says is that we're stuck in xstart, so we didn't go any further. And this guy is in a 2A state with a DR other. That's a nightmare. And also, look at this. This is our router ID. And why the heck are we trying to... We're seeing a neighbor, and we can check these addresses here in a moment. 51 and 53. Let me just peek at those addresses for a moment. I'm going to keep that pen up. I just want to go over here and... Okay, that's 53. And R1 is at the bottom of the screen. Is 51. Okay, so right here. So what this is saying, if I bring that window back up, I got a lot of windows open. That was R2. There's no way that we can be pairing with those two devices with the router ID of 2222 because that's our router ID. So something is fishy. And also, yeah, something's fishy with that. So let's take a look at router 1 and router 3 and see what's going on with those guys. This is a great lab. I am so grateful for the time NetworkChuck you put into this to create it for us. So let's go to the CLI, and on R1, let's go into privilege mode and do a show IP protocols. Make sure it's running. So this is, yeah, look at this. My router ID is 2222. So R2 is saying, yeah, my router ID is 2222. You can't have two devices with the same exact router ID pairing with each other. They won't do it. They have to be unique. Okay, so that's one problem. And then we have some network statements, which look good. We're including the loopback of 1111. Okay, so we need to fix this guy's router ID. Let's just see how he's configured. Show run, section router. All right, so router ID is mucked up. Let's fix that. Also, I'm going to fix this reference bandwidth challenge too. That's great. Router, I'll explain that as well. Router, router, OSPF 1. Router ID is 1111 for R1. And then this guy right here, auto cost reference bandwidth 1, that's not good. So the default reference bandwidth is 100. And what that means is that anything faster, fast Ethernet and faster, all looks like a cost of 1. That's with a reference bandwidth of 100. This reference bandwidth of 1 is just going to make every single link in the topology look like the minimum cost of 1, which is not accurate. So if we have fast Ethernet or... Anyway, we need to fix that because we should set it to 1,000 at least. Although I think all I have... do I have fast Ethernet? I think on all the interfaces, we may be running gig. So I'm going to make a couple changes there, and it's very likely to be set consistently because that's how you just do auto cost reference bandwidth. So I'm going to go ahead and do router, config T. I'll take the error if we're already in, no big deal. And router, OSPF 1, auto cost reference bandwidth 1000. And then we'll say router ID. That's going to assume that I need to configure it. I'm going to pump that in on a few devices. Copy. All right. Actually, I could do a show command first. Let's do that too. Show IP OSPF. I'll do that. That way I can see the output before I make the changes. So copy that on R1. We'll paste it in. Okay, so its router ID says 2222, and I'm going to do 1111. I already did. I'll do it again, and then end and clear IP OSPF process, and yank that, and then we'll do the same thing for. I think R2 is okay. Show IP OSPF. Yeah, it's got a router ID of 2222. That's good, and then we'll go to router 3, which we haven't been to yet. Great troubleshooting, fantastic. And I'm just gonna paste that in as well. Oh, I didn't change the reference bandwidth on R2, I don't think. So router ID, I'm just gonna hard code this too. All right, and I'm also gonna do R2 just to be consistent. Paste. Clear IP OSPF process. All right, yes. All right, and one of the things about the auto cost reference bandwidth is it's supposed to be set consistently across the board. So if that is in other places as well, I need to fix that too. And we only have two other places, and that is MLS1 and MLS2. So I'm going to actually take that same text that we just did and copy, and I'm going to do that on MLS1. Oh, that's so great. This guy believes he's 1111. All right, we'll fix him. Let's make him 11, 11, 11, 11, something different than R1. Great. And then we'll do an end, save, and a clear IP OSPF process. Oh, this is just chock full of surprises. This is great. And on the multi-layer switch 2, go to the CLI, enable, and then we'll paste, and it... Oh, come on. It's also 1111. Can't have everybody have a router ID of 111. They all have to be unique. So we'll fix him too. We'll call him 22, 22, 22, 22. Yeah, that's not in use anywhere else because we just set R2, R3, and R1, and those last two guys are the last two OSPF speakers. Save that and clear IP OSPF process. Yes. All right. Now, when we started this story, we were back at R2. Let's go back there again and show IP route. And now we have some OSPF routes, which also means we have some OSPF neighbors. Show IP OSPF neighbor. And we have an adjacency with R3. And we don't have an adjacency with R1 off of gig 0. So let's... Why is that? Why are we stuck in X start state? Easy for me to say, X start state. Okay, so let me check my interfaces. This is gig 00 on R2. That's connecting here, that one right there. Let's just do a show IP OSPF interface for gig 00. Okay, that looks super normal. It's got the default network type of broadcast, which is appropriate for Ethernet. It's got standard timers. It's currently a BDR. It means there's a DR on the network, which is R3 is the DR. It says right there. Okay, that looks all normal. And because router 2 is peering with R3, let's go check R1 and see what he's all about. So show IP OSPF interface. Now in a real router, you can do show IP OSPF interface brief. It's fantastic. It shows you just a one-liner for each one. So loopback 0 is in, VLAN 7's in, FA 0/1 is in, which is that WAN network right there based on the IP address. The process ID is 1, the router ID is 1, the network type is point. Okay, so that's so good. I'm so glad. Point-to-point is not a bad network type. And if both neighbors or all three neighbors agree to it, they'll just form full adjacencies. They're good. However, point-to-point assumes that we're not using a DR. It also, the timers are, actually the hello and dead intervals are the same, but it's not expecting to use a DR. And that's the problem here, is that R1, he won't be peering with anybody fully. Over this network, I should say, over this WAN switch, until we, wow, look at this. FA 0/1 right here. Look at that, he says full. He says full adjacency with R3. What does R3 say? Okay, maybe I'm going too fast. So, from R3's perspective, it has a full adjacency, or so it believes, with R1. And R1 state is a DR other, meaning I'm not going to be a designated router. And from R1's perspective to R3, it thinks it's a full adjacency, and it's not doing a DR because it believes it's point-to-point. And the question is, are we learning from R3? I'm curious. So this network right here on R3, the network that goes over here to the right is the the 128 network. Let me check my my VLAN assignments real quick. Yes, the 128 network. And I want to see whether or not, if we go to this router and do a show IP route, connected, without the slash at the end. So there's the network that's at the remote site 2. I want to see if that route is actually in R1 if it learned that. So we'll do a show IP route OSPF. Oh my gosh. Yeah, it's not even here. So that is a great, great spoof because we have wrong network types on this interface on R1. And so even though the output looks like full and no and point to point, the other side says full and DR other, they are not exchanging routes. Otherwise, R3, unless the interface isn't involved in OSPF, show IP OSPF interface. I took a look at my map here. So that's site 2. And what interface is that? That is VLAN 80, I believe. 129 to 158. Oh yeah, it is right there. So that's gig 0/1 that is enabled for area 0. Wow. So we are not, even though it looks like we have kind of a neighborship between R1 and R3, we don't. I mean, it's not a functioning neighborship. So I'm going to fix the interface type. Show IP OSPF interface for gig, was it 1/0? All right. And hold on a second. On R1, let me hover over this interface for a moment. This interface is FA 0/1. Holy cow. Show IP OSPF interface. I wish we had the brief command, but we don't. Oh, there it is right there. Okay, so it's enabled, but it's point to point. Let's go ahead and fix that. Config T interface FA 0/1. This is a great, great trick to, or a great, not trick, but a great problem for resolution. And no IP OSPF network. And what that'll do, if I can type in network, that'll remove the artificial one, and it'll take the default based on the Ethernet encapsulation at layer 2, and it'll default to a broadcast network type. And I'm going to do a clear. Wow. Wow, 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 wow. Okay, show IP OSPF neighbor. All right, so this is better. I've got, you know what I'm not seeing though? I'm not, I'm not seeing console messages that are saying, hey, your neighborship came up or your neighborship just went down. I'm not seeing any of those, but here's our neighborship. We have a full adjacency with 333 and 222. Man, so show, so great. Show run, section router. Oh, no log adjacency changes. Beautiful, beautiful. That's why we weren't seeing any of those log messages come up saying, hey, the neighborship came up or the neighborship went down, especially when I did the reset and nothing showed up. So I'm going to go ahead and go into router configuration mode and say no. I'm going to say log adjacency changes. And I just want to verify it's going to work. If that's the only problem I had there. Clear IP OSPF process. Oh, yeah. All right. Oh, that's fantastic. That's fantastic because I wasn't seeing those. I was like, what? Is that working? Okay. All right. That's great. I'm going to save that. Now, as we continue to troubleshoot here, and the camera's still rolling, so if you're hanging in there with me, this is a wonderful lab. Thank you, NetworkChuck. It's fantastic. So let's go to router 2, which is where we started off, and we're trying to get a route up to the VLAN 10, which is 10.67.A30 network. And let's do a show IP route. I'm going to say OSPF learned routes. And, oh, look, I have a route. That's fantastic. Let's see if it works. Let's go to our client, and let's hit the up arrow key. And we have a reply from 10.67.83.5. Oh, I'm so glad to see that. Let's do a trace also to verify the path. A trace RT space to 10.67.83.5. So we're pinging from this PC here at site A to this PC up here. So I thought the ping worked. And now we're showing all of our hops at 65, which is, oh, that's not good. 10.67.83.5. Oh, 65. Oh, I'm so sorry. It's like, hey, Keith, they're pinging. They're tracing the wrong address. So let's do a trace to 5. All right. Otherwise, I think, okay, now we have a layer 3 loop. Boom, 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 boom. Okay, so we have connectivity from, and let's go ahead and ping PC2 as well. We're almost done, I think. Infrastructure is solid. This is .21. So let's do a trace up to 21. This is from the PCA right here, being routed up to PC2, which is in VLAN 20. Okay, that looks good. The requirement was full connectivity between all the clients. I think we just did that. Let's also ping from PCA down to PCB. This guy. So this guy is. Let me close that. This I see the light at the end of the tunnel. This is at 131. So we'll try to do a trace to 131. Okay, I'll take it. That's great. That works. So PCA, site A PC to site B PC, it works. Site A to PC2 works, and we also could go to site B and do a home run up to PC1. So let's go to the desktop there, go to command prompt. I think we're almost done. And we'll do and just to show us where we're at this PC right here, and we're going to go to this guy at .5. So trace up to 10.67.83.5. Looking good. Let me see if there's anything else that the requirement was full connectivity between clients. I think we did it. So if we go to this PC here, yeah, we just pinged all the devices from every other device. So what I thought might happen was the public server out here, we're running NAT on R1. And I thought there could be some really great mischief that's being done there on R1. But there's no requirement in the lab to go out to that public server. So I don't think we need to troubleshoot that if there's nothing to troubleshoot. All right. Wow. There was a lot of gotchas in that lab. I am so grateful for NetworkChuck for taking time to integrate all those problems. And I will post this. So I did the recording. We're in the middle of the pandemic right now, and so my internet stream has often been cut or couldn't reconnect to the server, so I did this in one take. I'm going to upload this. It's going to premiere on the 4th of April. I'll just upload it as is, no edits, and I'll also post it as a premiere so we can all watch it at that time or later. It'll be there as well in addition to that. So I have been challenged today. That took, I have to go back and look at the clock, but that might have taken an hour and a half maybe for me to walk through all those pieces. And one of the things that helped me was basic knowledge of the topology. That really did help because I knew where things were as far as IP addresses and so forth. I also had documentation regarding the actual subnets and their IP addresses. One thing I was expecting that didn't happen was I was expecting some IP addresses to be in the wrong subnets. So that, this IP address is in the wrong subnet, can't reach its local gateway, and it kind of looks like it's the right IP address, but there was none of that. There wasn't a hard coding of MAC addresses. There was some good security with BPDU filter and and BPDU guard that were fantastic. And then we had the issue where we saved all the configs. We still had this loop condition. I didn't see where it was coming from because we had spanning tree on all the VLANs. And then we simply saved the project, re-brought it up, and it healed itself. Although I think that we shouldn't have required a reboot to do that, because once you have spanning tree and it identifies the parallel paths and blocks on the redundant ports, it shouldn't be a problem. So thank you very, very much. If you're new to Cisco networking and you want to pursue a CCNA, we'd like you to join us on this channel here, Keith Barker Networking on YouTube. There's a master playlist. That would be your next step if you're brand new to CCNA, and go to YouTube, this channel, check out the master playlist, and just go down and look at the videos that are of interest to you. We have videos on trunking, on VLANs, on DHCP snooping, on dynamic ARP inspection, on port security, on routing, and a host of other topics surrounding CCNA. Also, if you haven't already, please subscribe to NetworkChuck's channel. He's fantastic, a great individual to follow and learn a lot from, have a lot of fun while you're doing it. Also, if you enjoyed any part of this content, please feel free to join us here on the Keith Barker channel. Also, a lot of people on this channel have CCNP level knowledge and above, but they come back to help. So if you want to help on the Discord server or come to the live streams or the premieres and help answer questions for other people, everybody is welcome. Our goal is to move the needle a little bit for every individual and help them get a little bit better at the technology that's going to improve the quality of their lives. So again, a huge thanks to NetworkChuck for all the time you put into this lab and give me the opportunity to troubleshoot it in this live recording. And I'll see everybody in the next set of videos. Thanks everybody, and have a great rest of the day.